Sir,
Yes.
I went to the bookstore last week and they said they don't have a physical copy of the textbook. You know if it's on back order or if it's arrived yet?
I have no clue. So my message is go on Moodle, click on it, and buy it there. So if you like a physical copy, then yeah, I don't know. Sorry.
It's better for me that I have a physical copy. That's why.
Yeah. You can see if I can ask but you know, I think you're going to be as successful as I will be finding it. So okay, all right. So people 177. Okay, let us start.
Hello.
Hello.
I just have a doubt about the quizzes on Moodle. Are they counted towards the final grade, or do we have to just submit assignments that are counted towards the final grade?
It's the labs are counted.
The labs are counted. Okay. All right.
But not everything you do but that's within the book, then this is just for practice. It's for you.
Okay. All right. Thank you so
And
much.
by the way, I've had a discussion about some of the exercises in the, say, in chapter 1. Some are not so easy, and so you shouldn't get too scared if some of them are too difficult for you. The labs are easier, I would say, and they are closer to what you're going to have at the midterm exam too.
Okay, thank you so much.
No problem.
Also, sir,
yeah.
When are the MyLab exercises due?
Can you say that again?
When is MyLab due for like each chapter?
Oh, it's written in the course outline. So I think it's maybe next week or the week after.
26th of September.
Okay. Cool.
Okay, so without further ado, let me share my screen. So today we do chapter 2.
Sir, one more thing about the MyLab.
Yeah.
Like I checked it out, obviously, but it says like 1 attempt per question. Is it possible you think that we could get maybe like 2 or 3 or something?
No, because
No? Okay.
you know, if there are 4 choices, then if you get 3 attempts, that's a bit easier.
Okay.
Like, do we have time to answer the questions, or like we have like a certain time for the questions on MyLabs?
Yeah, so you have as long as you want, but you know, it as long as you don't get disconnected. So which, all right, okay.
Sir?
Yeah.
So for the MyLab, we can't like answer 2 questions and save and then come back, because in math we can do this. We save the questions and then we come back and we continue.
So you can do that.
Oh, okay.
For like independent questions. But sometimes what you get is one question which leads into a second one, into a third one. So of course, if you go back, then the numbers might have changed.
Yeah,
so
I'm talking about independent questions. Yeah, okay. Thank you.
All right. Okay, chapter 2. Everybody sees me moving around?
Yes.
Okay, so yeah, so chapter 2 is much less work than chapter 1. It's about economic theory, data, and graphs. So yeah, chapter 1 was really a big overview of macroeconomics. Here we go into the more of the detail. So yeah, so the goal of the chapter is to distinguish between normative and positive statements. You're going to see briefly what they are, how we build theories. Is economic a science or not? We're going to see that. The kind of economic data we have very briefly. and how we show a theory to other people by graphing it. What's a positive, negative relations kind of thing. All right, so positive versus normative statements. So this may be contentious at times. So here I'm going to stick with what the book is saying. So let us start with positive statements, and let me give you an analogy with say other sciences like physics, for instance. So a positive statement is just a theory you have about the world. So so in physics you would say, oh, I think that if I drop a ball, it's going to fall. So that's my theory of gravity. I'm just describing the world. I'm just saying that's what you should do. I'm just saying this is what is going to happen if you do it. So in economics, it might be something like, so example, if we raise the minimum wage, it is going to create unemployment.
Teacher,
Yeah.
You're gonna post this, right? Your comments also.
Yeah. But it doesn't mean that, yes, it's always good to just write stuff down sometimes so you just stay awake. But yes, if you go get a coffee and you come back, but so I'm going to post that. Actually, I did that for chapter 1.
Yeah, I know.
So yeah, so this is what I mean by a positive statement. So it's just my best description of how the world works. And by the way, I'm not saying this is true. So we have plenty of evidence. It's not really true for the level of minimum wages we have, especially in the US. But it's an opinion about how the world works. Now, what you do with this, for instance, if the government says, "Oh, I would like to, I don't know, I would like to help workers, or I would like to lower unemployment," for instance, then you can use your theory and say, okay, if you, for instance, if you want to lower unemployment, then you should lower the minimum wage. Now, maybe I sound like a heartless economist when I write these things. I should maybe have picked another example, but you get the point. And but normative statements are more rare in the sense that economists don't like too much making them. So oftentimes when some government asks us, what should I or should I not raise the minimum wage, then an economist is going to say, oh, well, on the one hand, you can raise the minimum wage to help workers have better wage, better income, but it's going to maybe create unemployment.
Professor?
Yeah?
I just have a question. Wouldn't hiring the minimum wage actually increase or wouldn't hiring the minimum wage lower unemployment? Sorry, because it would incentivize people to go work for like, I guess, lower risk, easier to obtain jobs for more money than
it would encourage
yeah, exactly. It would encourage
it would hire less people because they can't afford to pay as many people that amount.
So many things can happen. So I can tell you what the evidence is. So in the US, there was a famous study by David Card in the 2000.
Oh, recourse.
Yeah, so there was a famous study by David Card who compared the unemployment rate of two states, in which one state increased quite significantly its minimum wage compared to the other, where it stayed the same. And he compared how did the unemployment change in one state and the other. And yeah, they couldn't find any difference. So at the levels that the minimum wages are, the best consensus we have so far is that it doesn't matter too much for employment. But question is, what would happen if, for instance, I raised it to $100 an hour? So then what does somebody have an intuition of what would happen?
Everything
Level
would
of
go up.
inflation.
Yeah. Okay, but imagine that the price level doesn't change.
Then the companies will go bankrupt.
Yeah, exactly.
Yes, exactly. Well, they would just not hire anybody. So that's the difficulty about economics is so if I say a statement like when I drop a ball it falls, that's a universal statement that's always going to work. But
it still
here
depends on how much you raise the minimum wage.
Yes, exactly. So in economics, all we say is contextual. It matters how much, when, in what context. If it's for if you add I don't know, a minimum wage for lawyers that was $50 an hour, maybe it's not too high because lawyers are paid a lot. But for any type of jobs, then 50 or $100 an hour would probably be too high. But if you raise it from 7 to 9 or 9 to 10, probably it's not going to change a lot. That's the best thing we know so far. Yeah.
Shouldn't the minimum wage follow the inflation rate for it to not really affect the employment rate?
So in a sense, yes. If your goal is to make sure that the purchasing power of the lower income workers stay the same, then of course, if price level rise, then you should raise the minimum wage at the same moment. The problem with that, though, is that there is some evidence that actually what drives inflation is our wages. Yeah, so but that's another story. I'm not going there. So it's complicated. Okay, so that's the difference between normative statement and positive statement. Usually economists stay there. All right, so why do they disagree? Well, they sometimes disagree about about which policy recommendation they would do, but oftentimes they disagree about topics where data is not that good. So when it's important topic and yet we don't have good data. So for instance, macroeconomics questions are super important, but at the same time it's difficult because it's the whole country. We don't have. So I will discuss later on how we build our theories, but yeah, for macro questions, is raising interest rate going to, increase the output, for instance, or lower unemployment? It's difficult to know because so many things are going on at the country level that we can't know for sure, and yet we would need to know that. But one thing that I would say about this, though, is if you put 3 economists in a room, they're going to disagree with each other. But if you make some other person that's not an economist enter in the room, then all of a sudden the 3 economists are going to look at each other and say, yeah, but we mostly think the same, and mostly different from that other person. So economists mostly agree with each other.
Is this like the study, is it largely subjective?
We would like it to be objective. We would like it to be a science. It's just that it's difficult. So for instance, yeah, we need to make a lot of assumptions about yeah, so about what is normative, what is positive, but also what assumptions we make when we make the judgment that we make. So
Of?
in a sense, if you want to know if something is a science or not, sometimes the problem is not how smart people are. And, economists are pretty smart too, but how difficult it is to have access to good data. So in economics, for instance, if you would like to have a theory that's as solid as in physics, you would have to, I don't know, say, okay, let me take planet Earth and replicate it 3 times. And then in one, the first Earth, I don't change anything. That's my control. And then the second Earth, I raise the minimum wage and see what happens. And in the third Earth, I lower the minimum wage and see what happens. And then I have these test samples so I can really see whether minimum wage is good or bad for employment, for instance. But we cannot do that because it's the economy is what we got. So it's we have to be clever about the ways we build our theories. And sometimes we would like to know a lot of answers to a lot of questions, but it's just impossible to know them. So that we do the best we can. But still, they are important questions.
Prof,
Yeah.
could you be able to give us another example for a normative and positive statement?
Yes. So another example would be, yeah. So if we raise, say, interest rates or say nominal interest rate, will it increase inflation or not? So that's a positive statement. So the positive statement is, I think if I raise interest rate, it's going to, or rather, it's better to see it's going to lower inflation. So that's my theory about the world. And then if the government asks me, oh, by the way, I would like to reduce inflation, how do I do that? Then my normative statement is, if you want to reduce inflation, you should raise interest rates.
So it's just about the syntax.
Yes, mostly yes.
Okay.
Because we're never saying something like, oh, you should do X, because I know from the bottom of my heart that the best world possible is a world in which you do X. It's just, if you want to accomplish some goal, this is what I recommend you should do.
Okay.
Okay, so theory is an abstraction from reality. So what's a theory? My best analogy, it's like a map. So on a map, you choose, first of all, you choose a region you're interested in, and what's outside your map you don't care about. You just say, oh, I'm interested in a map of Montreal, for instance. So I might draw some parts of that are not in Montreal, but it's just not what I care about. I care about this thing. So so in a theory, you have a theory that describes one phenomenon in particular. And then what's on my map, so I can say I want a map of the terrain, I want a map of the roads, I want a map of the weather, and you choose to neglect other phenomenon on it. So that's what we do in theory. We want to explain some phenomenon, and we don't care about the other phenomenon. So the thing that we're trying to do is choose the phenomenon we want to, what we want to explain, and ignore the rest.
So is a theory considered to be proven?
No, all the theories are false, but some are more false than other ones. So no theory is perfect. Even theory of gravity, it might be true, might not be true. It's just that I have good reason to think that the next time I drop my pencil is going to fall on the floor. But who knows? Maybe someday it doesn't anymore. So and you can never say, oh, the data shows that my theory is true. What you can say is the data shows that it's compatible with my theory. So thus far, I cannot really reject it. But the day that you make an experiment that shows that your theory doesn't work, then you say, okay, it's wrong. I have to throw it away and start over.
Okay.
So variables, what are they? They are something like X influences Y. So for instance, minimum wage, higher minimum wage. Yeah, minimum wage increases unemployment. So X is minimum wage. What's the impact of X is increases, and what's Y? It's unemployment. So this is what we mean by a theory. So it's a very simple theory, but that's all we say. It's a statement about how I think the world works. Or I could say another one. So for instance, if price goes up, then quantity demanded goes down. So that's another theory. That's theory of demand. Is it true? Is it not true? Well, I think in most instances, if instead of paying 12,000, I have to pay 24,000 for a car, then I'm less going to be willing to buy it. It's just that's what it's describing. The assumptions is everything that has to be true for your theory to be true in theory. So what I'm saying is, for instance, perfect information or you could say no transaction cost. So all these assumptions that we sometimes do, these we do them for the description of perfect competition. So we say, oh, this is how my mathematical model of how I'm going to describe the world. And it's a simplification of the world. Like I was saying, it's an abstraction for reality. It's a map where I choose to highlight certain features and ignore the rest. And by the way, I'm going to ignore stuff. So like in physics, you would say, oh, I know there's air resistance, but it's too complicated, so I ignore it. So I assume there's no air, for instance. And then prediction is like the normative part. If the price increase, yeah, it's just, so yeah, okay. Let me say that again. So given that,
teacher,
yeah,
would the clause ceteris paribus be an example of an assumption?
With the what?
The clause like ceteris paribus.
Yes. Ceteris paribus. So ceteris paribus is saying all s being equal. And we have to make it. Why? Because in society, in markets, in economics, everything changes all the time, and everything influences everything. So is it so it's true to say that, oh, I don't know, because everything influences everything. You can always say that, and you're always going to be right, but you're also always going to be useless. The thing is, we try to make useful statements about the world, and to do that, we have to make certain simplifying assumptions, and one of them is, okay, I'm going to assume that say, for instance, if the price increases, then the quantity decreases. And while the price increases, I'm assuming that, for instance, the characteristics of the good stay the same. Because otherwise you could say, oh, the price of the car increased, but it's because I installed heated seats and I changed the paint job and everything. So yeah, of course, then if everything can change, then who knows, everything could happen. But what you want to see is I isolate only X, the impact of X on Y, and I assume that Z or W or all the other things that could change don't change for my thought experiment. So this is the prediction is the last step. It's given my theory and given what just happened, I predict that this other thing is going to happen. Okay.
Sir, why
Yeah.
does X influence Y and not Y influence X?
Because
Just explain that.
it's
Sorry.
a convention.
Okay.
Sorry, can you go back just 1 second?
Yeah.
Sir, did you like just explain that?
Yeah,
Why,
it's just
X?
it's a convention. It's because when we draw graphs, we draw them this way. And we put X here and Y here. And we say something like, yes.
Oh, yeah, that's true. Okay.
So, but it's, actually, so I've heard that in some Russian economics programs, sometimes they would switch them around. They would say Y it versus X, just to see if students would get all confused when they change the letters. Don't worry, I'm not going to change the letters. But you know, a letter is just a letter. You can use whatever letter you like.
Professor,
Yeah.
Do X and Y work in the same way that they do in math, in a sense to where X is dependent on Y? So let's say like the price is dependent on the quantity, or sorry, like yeah, price is dependent on let's say the demand of a product or something.
Yes, that's what we're saying. So if Y
Okay.
is yes, yeah.
Okay, so X is always a dependent factor.
Yeah, it's kind of the same thing we were discussing. So maybe I have a big model where all the things influence all the others. So in that sense, Y would be influenced by X and X would be influenced by Y. But at some point, you have to have some kind of what we see exogenous thing going on. So you have to have a factor that was unanticipated that is going to influence something else. Otherwise, you cannot say really anything, basically. And usually
Okay,
what we're saying is X is independent variable and Y is dependent, meaning Y is going to receive the influence of X.
Okay, so for a theory, you always need an X and a Y. You need something that is dependent on something else.
Yeah, at some point, yes.
Okay, thank you.
So sorry. I mean, so think about, I don't know, the solar system. So is the sun influencing the earth or the earth? I don't know. So, but it's still there. I still have some theory of how the solar system works, even though like, I don't know if what influences what. But a better example would be something like in medicine. Like in medicine, you say, if I take aspirin, then I'm going to feel better. So then this is super clear. X is the aspirin and Y is me feeling better. So normally that's what we mean by X influences Y. But so in some macro macro models, it's more complicated than that, but that's how I would put it for now.
But here, les variables, they are X, like the price and the demand, not the fact that the price depends on like the demand.
Oh, yeah, sure.
Okay.
X is, yeah. Yeah, so this is the theory, actually. Yeah. I should put it here. And variables are, this is X, like, so the price, and Y, quantity. Yeah, good. Good of you to note that. Okay. Yeah, so we can go much faster now because we have already talked about all these things. So at some point, so here I make prediction. So I say, given that the price was increased, I predict the quantity demanded will fall. Now, exposed the day after, I can look and see, oh, did that happen or not? And then if it did happen, then I can think, okay, well, it looks like the data is in agreement with my theory, so I can keep it. But if then something completely different happened, then okay, I know that probably my theory is wrong and I have to ditch it. So that's what we're saying by confronting the prediction with evidence. And that's the whole scientific approach, is I have some preconceived idea, I try it, it works, good, I keep it, it doesn't, I have to change it. So this is the whole thing. And this works not only for economics, but all of science. I have some theory, I create it, I make some logical deduction with it, I then make some predictions, and I look at it and does it work, does it not work? If it's in conflict with reality, I go back and I change it. And at some point I keep it if it's good enough. Actually, is it how things work? Oops. Yeah. Is how things work all the time? Not really, or because people are attached to their theories. So sometimes people don't want to say, oh, my theory is bad. I want to, because I came up with it. I think it's good. And I want to explain, expose, oh yeah, but the reason why it didn't work is this other factor that, and my theory is still good. So how does knowledge evolve? It evolves, at some point there are enough people that say, no, this is bad, this is better, so let's change it. But yeah, in principle, economics, just like any other science, works in this way. It's a bit large. It's better. All right, so how do we test? Well, we said we test by confronting the predictions with empirical evidence. And yeah, it's just what I just said. Yeah, question?
Sir, before we move on,
yeah.
I have a general question. How do you expect us to like, man, I had a question in my mind, sorry. I'll think about it, I just forgot it. Sorry.
Okay, don't worry. So how do we decide whether evidence is good or it's bad? We use statistical analysis. And what is statistical analysis? Is just using the results of many experiments or many outcomes in the real world to use to decide where if something is true or not true. Because I cannot say, oh, I'm sure that my theory is wrong as soon as I observe one thing that happened that changed it. No, in the world, many things happen at random. At some point, you have to gather a lot of data to be sure that something is true or something is not true. And for that, so it's statistical analysis, but in economics, we use what we call econometrics, which I personally call interesting statistics. Because I think econometrics is tackles the most interesting statistical questions. Now, do we use millions of uncontrolled experiments in everyday marketplace? Yes, but at some point, but that's not, we never observe millions of transactions of people, or maybe we do when we have data like big data and transaction in markets, for instance. But normally what we would use is something like average data comparing things that happen in one country and the other, for instance. And then you compare the mean and you say, oh, it looks like the mean in one country is higher than the other, so that means something or something else. But this is what we meant by, so variables that interest in economists are generally influenced by many forces that vary simultaneously. So in models, we need the assumption. Ceteris paribus. All else being equal. Yeah, so these statistical techniques are econometrics. Yeah, and so that's what I was saying about economics. It's not that economists are not smart, it's because the topic is difficult. It's humans are varied, countries are different, time periods are different. Something that may have been true for the 1990s may not be true for the 2000 or 2010s. So we always have to adjust our theories. It's complicated, but important. That's what we do, why we do it. Somebody knows what or have an example of positive correlation or negative correlation?
Does it mean like it's proportional?
Yeah, when something goes up, then the other one goes up too.
Yeah, so an example.
Demand for overall production grows as population grows?
Yes, very good. So example. Or you could say also the same thing in reverse. So production increases when population increases. So here I'm not saying one is causing the other or the other is causing one. It's just I'm observing these two things at the same time. So normally large countries have that have large population also have larger GDP, for instance. And negative correlation.
Can you say, for example, like if the price of fuel increases, the demand of coal can decrease?
Yes.
Could another example of a negative correlation be that if the amount of houses being built increases, resources like iron will decrease, like the supply?
Yeah.
Professor?
What? Yeah.
For negative correlation, do X and Y move together as well, or do they move at different times? Because in positive, you have that they move together, but you didn't mention that in negative.
Yeah, so I haven't really said anything about time, but you could say, so it's the fact that one variable is higher when the other is lower, or one variable is higher when the other is higher. But if you want to say, oh, there's a delay in time, then fine, you just say it. So example. The sun rises, and later, like 2 hours later, temperature start to rise. So of course, it's not exactly true, but you see what I'm saying. Here, my theory is the correlation between seeing the sunrise and 2 hours later seeing the temperature rise. So it's just a description of this correlation that I'm seeing. It can happen. There can be a delay between one and the other.
Okay, thank you.
But there can't be a delay for positive correlation.
Yeah, for anything.
Oh, okay.
So you can always let me say. So what's temperature rising? It's the amount of cold air decreasing. So if you could say sun rises and 2 hours later the cold air decreases. It's a negative correlation.
Sir, I
Yeah.
don't get why price rises when the demand falls in the correlation. It's more of a causation though. But if the price rises, of course the demand is going to fall.
Okay, it's a very good question. So when there is causation, there is always correlation. But when there is correlation, there is not always causation. So, so what we see is correlation does not imply causation. But here it's true. If someday the price is very high, then probably people are going to. But yeah, it's not. So yeah, we're going to see in the next chapter how supply and demand work. Here I'm saying quantity demanded, and not the demand itself, or the equilibrium quantity exchanged. I'm just saying, in the mind of consumers, they are going to be less interested in buying if it's expensive. That's all I'm saying. Now, a good example of why this is not the case. There was a Russian Tsar at some point who observed that there was a lot of disease and big epidemics in Russia, and he wanted to understand why. So he sent his emissaries to different regions, and then they came back and they said, yeah, in some regions there are a lot of sick people, and there are also a lot of doctors. So then the Tsar said, ha, I understand now, doctors are causing disease, so let me get rid of my doctors. So that's in his mind, that was, okay, the doctors cause the disease. Is that justified? Not, probably not. So that's what we're saying by saying correlation does not imply causation. So doctors are correlated with disease, but it's not that doctor caused disease. It's rather that the fact that there are some disease at some place will make doctors go there and cure people.
So it's like two variables that happen to be observed at the same time.
Yeah. Exactly. So you observe one movement in one variable, one movement in another variable. So that's correlation. That's it.
The way I've learned it is that, for instance, number of dogs and number of cats, they are both are correlated, but they're not caused by each other. Like the number of dogs has no impact on the number of cats. This is what correlated is, and cause is, for instance, the job, the number of hours you work, and the money in your bank account. These are cause. And this is the way I'm learning it. Like the sun rises and 2 hours later temperature starts to rise. It may be true scientifically, like if the sun is in the sky like at lunchtime, of course it's gonna be hotter.
I'm not sure if I got the last part, but I think I agree with what you said. The thing, so there's a yeah, it's this goes way deeper than what I would like to go to. But so there's a school in economics and labor economics that says no causation without manipulation. So the only way to establish that something causes the other is if you manipulate it. So, for instance, what I would have to do is to really show that the sun is responsible for the temperature, is someday to make the sun stop or rather remove the sun from the solar system and see how temperatures change. And if I'm not able to manipulate the sun, that I cannot really establish that one is the cause of the other, for instance. So that's going quite deep. Yeah, I don't want to go further. Okay, this is easier. So index number, what's an index number? It's just some number that's not based on the value of the number itself, but on divided by the value of it at the beginning of a period. So for instance, if yeah, actually it's very well explained here. So it's the value in a given time period divided by the value at the base period. And this is weird, so it would be something like here it should be multiply, not this weird symbol there. Let me try to erase it. Yeah. So it's just expressing something in percentage of what it was in the past instead of itself. So for instance, yeah, CPI. So CPI, somebody knows what this is?
Consumer price index?
Yes, exactly. And there is PPI, producer price index. So what we're saying is the level of consumer prices was a certain number in 2000. Then what was it in 2001? Well, it was 2% higher, for instance. So that's the index. And what do we use these things for?
I'm not sure, but is it to calculate the GDP?
No, not really. So the GDP is just what we can. Yeah,
is it for the price of living?
Yeah, that's the consumer price index.
Yeah. Okay. Oh, okay.
So what do we measure with that?
Inflation?
Yes.
Oh, inflation. Yeah.
But on a base value, it's just measuring the price, the percentage of change.
Yeah, exactly. since the base period. Exactly, that you couldn't see it better.
Sir, can you explain it again?
So it's, well, I'll go to the next slide. It's going to be evident. So here, for instance, look at steel. So I'm not saying that the value of steel produced in some country is 100,000 tons. What I'm just going to say is, okay, imagine it was 100,000 tons in 2010. Then how much was it in 2011? It was 105 about. So it means that it was 5% higher than 2010. And then that I can track the change over time. So here I see that in 2020, it was about 25% higher than in 2010. And
Sorry.
Yeah, go ahead.
Oh, sorry, Professor. Would you be able to go back on the last slide just because I missed one bit that you wrote?
It's just that before there was a weird symbol there, so I prefer. Oh, yeah. CPI is Consumer Price Index. PPI.
Yeah, I missed PPI. Yeah, thank you.
So the index numbers are expressed in percentages.
Yeah, exactly.
Right. Okay.
It's a good thing to write down.
Mr. I also have like a question. I don't understand like difference from like a consumer and a producer price index.
Oh yeah, so it's just that I don't like when I get the slide and it's written, oh, there's CPI, and you know what good does that do to just throw a 3-letter word and nobody knows what this is. So I prefer to say what this is. So consumer price index, producer price index. So in a few words, it means that so I have some basket of goods. So for instance, CPI. So what I'm saying is, oh, what do consumers buy generally in the economy? Well, they buy food, they buy cars, they buy gas. And then what's the price of, so given the amount of food, of gas, of house, or everything they buy, how much do they spend on average on that? So that gives you a sort of index of the price of living for consumers. And then you can compare that with a year later and see, oh, did the price of living increased or decreased? So that's what we use it for.
Okay.
Okay, so that's yeah.
Sir.
Yeah.
Is the base price or the base index, is it 100?
Yes. So you choose your base year and you run with it.
Okay.
And by the way, so its usefulness of that index is percentage may always be compared with each other. So for instance, here I want to look at the evolution of steel and newsprint. So I just say, okay, there's whatever the number was of newsprint, I see it's 100 in 2010. Whatever the quantity of steel was in 2010, I see it's 100, and then I see how it evolved. So I can look on the same graph. I can put newsprint and steel. I don't have to care about what if this is in tons and this is in the quantity of newspapers or whatever. I just look at their evolution over time. And what would you say? So would you say that steel or newsprint is on the rise?
Yeah.
Steel.
Yeah, steel is on the rise.
I have a question.
Yeah.
So you said that let's say the the increase of steel in 2020 was like about 25%. But
Yeah.
that's comparing it to 2010. If
Yeah.
you have to compare, let's say 2013 and to 2015, would you have to change your base year to 2013 to the right percentage?
Yeah, of course. If you want to say what's the change between 2013 and 2020, for instance, then you have to say that this is 100. So
Okay,
this,
so like your base
yeah,
year would change from 2010 to 2013.
yeah, that's just that's how percentages work. Yeah.
Okay, thank you.
All right, so that's and by the way, what's this called? This is called time series type of data. Because I'm looking at the same thing here still over time.
Sir,
and
I have a silly question.
Yeah.
In French, I know we say indice base 100. Is it in English? Is it the index base 100?
What do you say in French?
Indice base 100
Never
for
heard of
the
that.
base year.
Yes, okay. Maybe.
How do we say it in English? Is it index base 100?
Yeah, I guess.
Yeah, that's what it is.
Okay.
Yeah, he just say it's a base year and it's 100, but yeah, I could put 1 there and look at compared to 1. So I would have 1.1, 1.1.3. I decide what my base number is.
Okay, thank you.
And then, okay, then more difficult question. So observe the two series. Can you say something about how they're correlated?
It's a negative correlation.
Yes. Yeah,
as the price of as the steel increases, neoprene decrease.
That because they're moving in opposite directions.
Yeah.
Sir, what is that line in that is like between steel and newsprint?
Oh, it's just to keep track of where 100 is. So if I know if I'm above 100, then there was some increase based to the base year, and if I'm below, there was a decrease. Yeah. So does that mean that? So I think there's only one explanation: is every time there's more newspaper printed, then the steel industry goes bad. No, I don't know why this is the case. There might be some theory, there might not be. Here, all I can say is I observe that they look like they move in opposite direction, but I have no clue why. And it's true, I have no clue why this is the case. It's just so happens that this is. It looks like this is the case. Okay, so this is it. So this was a time series. Now another type of data is cross-section. So cross-section is not the same thing observed over different periods, but rather the same things observed at the same time, but in different places, for instance. So you could say like, oh, what's the steel production in Canada, US, Mexico, France, Spain. So in 2010. So again, you compare them, you look at them. And so, yeah, one way to represent them is scatter diagram. However, they don't show a scatter diagram. Let me try to see a scatter diagram to show you what this looks like. Yeah, scatter plot is like this. So that's quite big. Yeah. So here you have, for instance, yeah, input, output, and then you represent what happened. So this is what we're saying by saying we use statistics, because the relation is never perfect. But what we take is we take a large number of observations, and then we can deduce our theory. So let's see example. And this would this be a positive or a negative relation?
Negative.
Yes. Oops. Why? Because here when x increases, so this is x, then y decreases. So I could draw some line there that shows on average what the relation is between one and the other. Yeah, and this is more akin to cross section, but I'm going to show you yeah, so this is what we say when we mean cross section. It's just different places. So here it's what is it? It's the average house prices. So it's in 2018. So I have 1 year, and I look at different places. And where is it the most expensive? So it's in Ontario and British Columbia. So here, I guess it's the demand that comes from Asia. Everybody wants to have a foot in Canada. So there's a high demand for houses there. So that drives prices up. And Quebec, yeah, Quebec is not too bad.
Can you flip back to the last one just for 2 seconds?
Yeah.
Sir,
Yeah.
I probably have missed it. Was it different from cross-sectional data and time series data?
So cross-section is, for instance, like this. So you have one time period, 2018, and you look at different places. If you, and time series is you have one, say, place or one variable, and you look at it at different time periods. So 2010, 11, 12, 13, exactly.
Okay.
Yeah.
Sir?
Yeah.
So there is no X and Y in the cross-sectional data?
Yeah, so the thing is, this is only one variable. But then I could, if I had a second graph that was looking at, I don't know, what would be correlated with house prices, like economic growth, for instance.
Interest rates?
Yeah, but thing is, the interest rates don't vary all that much in Canada, because financial markets are super integrated. So the sort of it, yeah, I would say something like yeah, economic growth. So for instance, in Alberta or British Columbia, you have high economic growth, and you have high house prices because everybody wants to move there, for instance. So then, so that would be one variable, and you would need another one. And then what you could do is do exactly what you did there. So you would have, say, economic growth as X and house prices as Y. And you would put all the points for Quebec, Alberta, British Columbia, Ontario, and it would look like this.
Okay, thank you.
All right. So this, we already talked about it. So, oh yeah, so this is, if we have something that relates, if you have a relation for which every value of x has only one value of y associated to it, then we call it a function. So for instance, this is a function because for every value of x, there's a single value of y. So I can show you different functions. So yeah. So this is a function. And then something like, say like this. Would be a function, but something like this wouldn't be a function. So function, and then not a function. Here you have x, you have y. And why is this not a function? Because for this value of x, for instance, you have one value of y here and one value of y here. So, but this works because for every value of x, you have a single value of y associated to it. So in mathematics, you would have, example, f of x or y equals x squared. So that's a function. Because for every value of x, you have a single value of y associated to it. Okay. Yeah, so this is an example of function. So for instance, here you observe wage income and consumption expenditure. And for wage income of, say, yeah, I have the numbers here.
Sir,
Yeah.
I was writing, is x a function of y or y a function of x for the last slide?
Y a function of x. And
Okay.
sometimes what we write is actually y equals f of x. F of x is a function of x.
Thank you.
Yeah, so for instance, here we observe that if somebody has no wage income, then they consume $800. So we are at P. Then if they have a wage income of 2,500, then they consume 2,800. And we are at Q here, and that this is how we describe our relation. So is it positive or relation negative correlation?
It's positive correlation.
Yes. Wage.
Sorry, sir, would you be able to go back to the last slide for just a second?
Yeah.
Thank you.
All right, so this is it. Yeah, so this is, we already talked about this, so it's just re-saying the same thing. So positively correlated when the two variables move together, negatively when they move not together. When they are, when the relation is a straight line like this, or like this, we'd say it's a linear relation or linear function. And when it's not a straight line like this, we say it's a non-linear function. So this I would add. Linear function.
Attention, attention, nous effectuons des essais sur le système d'alarme incendie.
Oh, sorry about this.
Attention, attention, we're performing tests on the firearm system.
Oh, I'm so sorry. I didn't plan this at all. What time is it, by the way? Okay.
Class ends in 4 minutes anyways.
Yeah, it's almost 3 o'clock, sir.
Try to close my door. That's very annoying. Well, all I can do is talk again. So what is the slope of a line? The slope of a line, we have already seen it last class, is the amount of unit that I change on the y-axis when I increase the units on the x-axis by 1, or here that's 2. Okay, good. So we increased from 4 to 6. How much did we change on the y-axis? From 4 to 3. So it's delta y divided by delta x. So here delta y was, how much was delta y?
-1.
Yes. And delta x was?
+2.
+2.
So the slope -1 divided by 2. And by the way, I could have changed not 2 but 1, for instance. And in that case, instead of having -1, I would have -0.5. So and the slope would be the same. I could have had slope.
So here it's price on quantity.
No, here it's pollution reduction and remaining pollution. Okay, so if I reduce pollution, there is less remaining pollution.
Okay.
So it could be -0.5 divided by 1. It would be exactly the same slope.
Sir, just to
Yeah.
be sure, that can be considered like as a negative correlation?
Yes, exactly. Yes. And the thing about the straight line is that the slope is the same everywhere. So slope everywhere. And this is different from this case, where here the slope is not the same everywhere. So here we say it's steeper because it's more abrupt. So it's like if you have a steep slope in ski, then it means that it's a difficult ski slope to ski and you have to be an expert. Whereas here it's not a steep slope, so it's a gentle slope. So it's close to 0. And when it's horizontal, it's completely 0. And you measure it the same way. So here, if I increase by 1 unit, I decrease by 1 unit. So the slope here is
Attention, nous effectuons des essais sur le système d'alarme incendie.
and here the slope
Attention,
is
attention, we're
minus 1 divided by how many? By 6. So you see that the slope is changing from here to here to here to here. It's almost finished. Right? Oh yeah.
Sir,
Yeah.
to find the slope, would we be able to use the like the math formula? I think it's like y2 minus y1 divided by x2 minus y1. I mean x2 minus x1.
Yes, yes. You know, if I want you to compute a slope, don't worry, I'm going to give you all the elements needed to compute it. Well, it's kind of impossible to teach in these conditions. I would say let's finish it for now and continue next time. We still have like 2 slides maybe, but yeah. Are there some questions about what we've seen so far?
Personally.
All right, so well, I see you Thursday then.
Thank
Bye.
you. Bye.
Thank you.
Bye.
Thank you.
Bye.
Thank you.
Have a
Take
good
care.
day.
Bye.
Bye-bye.
Thank you.
Have a good day.
Have a
Thank
good
you.
day.
Bye, sir.
Bye.
Thank you.
Goodbye.
Are we able to do the quiz now, or it would be more after the other class?
Oh yeah, you can do almost all of it.
Okay, if I finish the chapter 2, I can do.
Yeah,
I can do the quiz.
it's almost finished. I can show you what remains is. So this is increasing marginal cost. So that's an example of increasing slope. And minimum, maximum, and that's it. So
All right, thank you.
thanks.
I do have a question.
Yeah.
For the MyLabs, I've tried every single code I can find with the email that I got from the bookstore. I tried with the stuff that other people told me to use, and it just doesn't seem to work.
Hmm.
I was wondering if you had a code that you know works or something.
Did you try just your student net name?
Yeah. Oh, net name? No.
Yeah.
But I tried the student ID.
Yeah, maybe that will work.
Okay.
Sir,
Yeah.
do we have to read the textbook? Do you recommend?
Yeah, I highly recommend it. For one reason, that's because it's a class that's given to many sections at the same time. So at the end,
what?
it's this class is given to many sections at the same time.
Yeah.
So so the way that other teachers teach may be a bit different, but there's one thing that's constant is the base material we're using. So if you want to be prepared well, it's good to read as much material that's coherent, that's the same for each section, and the textbook is the same.
Okay, got it. Thanks.
So I have a question.
Yeah.
Are we expected to draw graphs on MyLabs? Because I've never used it before. Am I expecting to like use like the software to create a graph or things like this? Will that be in the test?
Yeah, I've looked at the questions and some of them ask graphs, but they are not too difficult. It's pretty obvious. They say, oh, click somewhere and then click somewhere else and then click somewhere else, and you make your line this way. So you should
I had some
train
problems
yourself
with
a bit.
the increasing of curves on that.
And I have another question. Do we need like a graph calculator, a statistic calculator, the professional one, or not at all?
I wouldn't think so. No, I think not.
I think not, no, because there's, I don't know, some people told me that you need to use the calculator with the graph assistant on it. I don't know if I don't have one personally. I'm just wondering if we need it for our exam. Are we even using a calculator in MyLabs? No. Or are we allowed one?
I would say anyways, it's hard for us to prevent you from using one on the side. But yeah, I would say a normal calculator would be enough.
Okay, thank you. Appreciate it.
So I tried the what's it called, net name, and it hasn't worked at all.
Okay, what's your name?
Sebastian McLean. McLean.
Seb, have you tried changing your browser?
Yeah, I just did.
Shit. I don't know.
So say your last name again.
McLean.
Okay. Yeah. So I'll try to email you a code that should work.
Okay. Thank you. Have a good day.
Have a good day. Okay, no other questions?
I have a question, sir.
All right, go ahead.
Yeah, is it normal that the teacher's name in the MyLabs is Moshe Lander?
Yeah, that's the name of the coordinator of the class.
Okay, thank you.
So have a nice day.
Have a nice day.
Did seem to have some issues with certain questions where I believe I plotted the correct graph, but it still marked me wrong on it because of like the 3 points for the curves.
Yeah, exactly. That's what I was talking about when I was talking about the curves. So I would recommend trying as much as possible until you get it right. And then you can try the labs.
Yeah, I'll try that a little bit more next time.
Yeah, it can be tricky to learn how to use these tools. So I myself, I've obviously never used it. But I've tried and it's doable. Okay, so any other questions? All right, so have a nice day, everybody.